This is question 30 from the June 2019 Regents, and it states, in right triangle PRT, angle P equals 90 degrees, altitude PQ is drawn to the hypotenuse RT equals 17, and PR equals 15. So all I did was I read this top part here, and everything that's listed there is already in my diagram, but it's always important because sometimes important information is hidden up there to read the whole thing. Now it says determine states the nearest tenth the length of RQ. So I'm going to put an X right here for RQ so that X represents the distance from Q to R. So before I get further into this problem, I just want to talk about this diagram because this diagram shows up quite a bit. This is a right triangle with an altitude drawn. And this is really special because there's actually 3 triangles listed here. There's this green triangle, there is this blue triangle this way, and then the big triangle that has them all together, I'll put in pink. So there's 3 triangles, and all 3 of those triangles are similar to one another. The reason why that is you can create a sequence of transformations and they can map on top of one another. So the one that I like to show is this green triangle here. So this green triangle, I want you to imagine there's a pink dot here and a purple dot here. Now, if I was to take this green triangle and I was to transform it, meaning to rotate it along that right angle like this, imagine it dropped right down. So I'm going to leave that right there for a second. So I'm imagining that this triangle here spun around and dropped down to where that green one is, right? So going in this direction. Now, I want you to remember that that pink dot would be here and that purple dot would be here, right? So that's where they fell when that triangle fell over. Now, if I was to resize this again and make it larger, that purple dot would fall over there and that pink dot over there. So what those dots are representing is congruent angles. So in a triangle such as this, that pink dot, I'm just going to get that green out of the way for a moment, this pink dot represents this angle being congruent to this angle here. And this purple dot represents this angle being congruent to this angle here. And of course, right angles we know are always congruent. So for that reason, to help me remember that transformation, I use the dots to show which angles are congruent. So in a situation like the Regents question, I just go ahead and put my dots right in. I know that this angle that's split towards the top is going to have one of each. So I'm going to use purple and green in this situation. And I know that each triangle left and right is going to have one of each. So this triangle over here on the left already has a purple, now it needs a green. And the triangle on the right has a green, now it needs a purple. So now what I did was I helped myself to organize to recognize which angles are equal. And now I can redraw all 3 of the triangles. So I do this each time. I understand that there are tricks that some people have learned that will help you to not have to redraw the triangles, but I really do think it is better just to redraw them, because if you learn too many tricks, you don't know when to use them and how to use them and how they're helpful to you. And if you just redraw the triangles every time, there's no tricks. It's just understanding proportions. So the one thing I do like to do is I mark left, right, and big. So this is going to be my left triangle. This is going to be my right triangle. And this is going to be the big one with all of them. All 3 are going to have right angles. So that's why I listed right angles in all 3 of my new triangles. And now I'm going to put a purple angle in each. And I'm going to put a green angle in each. Now I'm going to list the sides. Now if I take a look, my purple angle in my left triangle is P. So now in my left triangle near the purple angle, I'm going to put a P. My green angle is T and my right angle is Q. So I'm just labeling the triangles. If I look at the right triangle, my purple one is R, my green angle is P, and my right angle is Q. If I look at the large triangle, my right angle is P, my purple angle is R, and my green angle is T. Now I can plug in my values. On my left-hand side, I don't know how big PT is. I'm just taking a look at my larger diagram, so I have no idea how big PT is. So I can't put anything here. I have no idea how big QT is, so I can't put anything here. And I really don't know how big PQ is either, so I can't put anything here. So that's a big hint that I'm probably not going to be using that left triangle at all. My right triangle, I do have some information for. This side RP is right here. That's 15. So I can go ahead and put a 15 here. Then it wants to know what QP is. Now QP is over here. I don't have anything for that, so I'm going to leave that blank. And RQ, this guy here, can be found right there. That's our X, so that's a big deal. I'm going to put an X here. So I have a lot in that right triangle. Now let's take a look at the big triangle. This RT is going to be this full side here. So that's actually going to be 17. So I'm going to put a 17 here. PT is this part over here. I don't have that. But PR I do have. That's that 15. Now that I have all three right triangles redrawn and all of their lengths drawn in, I can see that I was right in my assumption that this left triangle is not helpful. I have nothing listed there, so I'm not going to be using that triangle. But now I have two triangles and their sides match up, so I can use that to make a proportion. This X value matches with this 15. This 15 matches with this 17. So when I write my proportion, I can write X over 15 equals 15 over 17. Now this is great, and from here it is just algebra, right? We can use our proportion to solve, and we're going to be cross multiplying. When I cross multiply, I do not multiply first. I write it as a product to make sure that if there is distribution, I don't forget. So that's just going to be X times 17 equals, and then if I multiply this way, it is 15 times 15. So I know that 15 times 15 is 225. So I can write this as 17x equals 225. Divide both sides by 17. And I get my final answer, which is 225 divided by 17. And that would give me X is equal to 13.23529,412. Now, if I go back to the instructions, I'll notice it wanted this to the nearest tenth. So again, I always write my unrounded number on the Regents first because I want to make sure that if it is a rounding mistake I make, that the people grading my Regents know. But 2 is in the tenths place. That 3 is not big enough to change that 2. So my final answer is going to be 13.2. I don't label, I don't use units, I don't circle, I just list my answer. So this is a beautiful 2-point question using mean proportions in a right triangle, which I just redraw them.